Hey guys, so let's talk about gas law. So gas law describes the properties and behavior of gases. Now, there are three parameters which we will look into before entering into the various gas laws. The first parameter is your pressure. Secondly is your temperature. Thirdly, your volume. Now, pressure has the unit to be in millimeter mercury or atm. Then your temperature is in degrees Kelvin or degrees Celsius, and your volume is in centimeter cube or diameter cube or liter. Now these are the three parameters which we'll be using to solve gas laws. Like I said, that gas law describe the properties and behavior of gases. Now, the first gas law which we will be looking into is your Boyle's law. Boyle's law was stated by a scientist named Robert Boyle. So Boyle's law states that at a constant temperature, the pressure of a given mass of a gas is inversely proportional to what? To its volume. At a constant temperature, the pressure of a given mass of a gas is inversely proportional to what? To its volume. So stating that mathematically, at a constant temperature, right, the pressure of a given mass of a gas is inversely proportional to what? Its volume. Now, you say that P is equals to what? K over what? Over V. So making this K subject of formula, we have it to be K equals to PV. Hence, the general formula for Boyle's law is P1 V1 equals to what? P2 V2. Now, in Boyle's law, we are considering only two parameters, which is your what? Your pressure and your what? And your volume. Now, remember that your temperature is what? It's constant. So, if you say questions which the temperature is being included or the temperature is being given, it is not Boyle's law. Such questions are ideal gas equation or the general gas law, which I'm going to be dropping the video soon. So now we have the application of this Boyle's law mostly is in respiration. We have it to be in respiration. Now, what do I mean by respiration? That is to inhale and exhale breath. To inhale and exhale what? Breath. Now, if somebody is sitting in his house or somebody is not doing any tedious work, the rate at which the person will breathe is different from the person who is running. Now, you sitting in the house, the pressure will be what? Will be lesser, right? And the volume of the air, that is the oxygen which you're taking in, will be what? Will be greater than the what? The pressure. Now, in Boyle's law, when there is an increase in pressure, there is what? A decrease in what? In volume. But when there is an increase in volume, there is a what? A decrease in what? In pressure. So respiration is an example. If somebody is running, the person will have what? A greater pressure than what? Than what? Than volume. Because the faster you run, that is the lesser the air which you're breathing will come in. That's why you see the person panting like and I don't see that kind of thing before now. So now the second application is filling in of air in bike tubes. So filling in of air in bike tubes. So as you continue to drive your vehicle, the air which was pumped into the tube of the tire will begin to do what? Will begin to evacuate. So as you apply a greater amount of pressure, the volume of that air in the bike tube will get what? Reduced. Right? Now, if the volume increases, the pressure does what? Reduces. So that is the application of what? Of Boyle's law. So graphically, we can say that Boyle's law can be represented as this. So let's say the graphical representation of Boyle's law. So we have it to be like this. So we have your volume and you have your what? Your pressure. So you have it to be like this. So this is your what? Your graphical what? Representation of what? Of Boyle's law. So the increase in what? Increase in volume is what? Is a decrease in what? In pressure. So the same way you can see do it this way: pressure, then volume. You can also have it this way. So an increase in what? In pressure is a what? It gives what? A decrease in what? In volume. So now I just have two questions which I would want us to solve quickly. I have two questions for us. So the first question is 375 centimeter cube of a gas has a pressure of 750 millimeter mercury. Find its volume if the pressure is reduced to 750 millimeter mercury. So let's solve this problem. So from your Boyle's law, you have the formula to be pressure 1 volume 1 equals to what? Pressure 2 volume what? 2. So the easiest way, like I keep on telling my students, the easiest way to solve this problem, first you see centimeter cube, which is what? Unit for what? For volume. As I said earlier, you see what? Millimeter mercury, which is what? Unit of what? Of pressure. Now see the two parameters are attached together. 375 centimeter cube of a gas has a what? A pressure of what? 770 millimeter mercury. Now if the volume and the pressure is being given as first part of the question, or second part of the question, now if it is being given as the first part of the question, it becomes what? Your first parameter, which is what? Your P1 and your what? Your V1. Now the equation which you are seeing, find its volume, find, that means that will become your what? Your second parameter, which is your what? Your second volume and your what? And then you are being given your what? Your second what? Pressure. So if there's any part you do not understand in this video, just play it again. You get to understand it better. And please help me to share, subscribe, and hit the notification button for more videos like this. So let's get this solved. So we have your pressure 1, which is 770 millimeter mercury, and you have your what? Your volume 1, which is what? 375 centimeter cube. So over here you have your what? Your P2, which is what? 750 millimeter mercury, right? So we are solving what? Question 1. This is the question that we are solving. 750 millimeter mercury. So your V2 is not being given. So which means your V2 becomes the what? The unknown. This is what you're looking for. So you make this what? A subject of what? Formula. So you say V2 from the formula. You say V2 is equals to P1 V1 all over what? P2, right? So having written that, now you do what? You substitute these values, right? So P1 is what? Is your 70 millimeter mercury times the V1, which is what? 375 centimeter cube, all over P2, which is what? 750 millimeter mercury, right? So this is your what? Your V2. So over here, your V2 is equals to, now your V2 is your what? Is your second volume. So millimeter mercury cancels itself. So 770 times 375 all over 750 will give us 385 what centimeter cube, and this becomes our what, our final answer. So 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. So 385 centimeter cube of the pressure. So they say find its volume if the pressure is what, reduced. So for the pressure to be reduced to 750 millimeter mercury, you need what, a volume of what, 385 what centimeter cube. Now watch something. As I explained earlier, I said if the volume increases, pressure does what, reduces. If the pressure increases, volume does what, reduces. Now watch something. Over here you have what, 375 what centimeter cube in 770 what millimeter mercury. Lesser amount of volume, greater amount of what, pressure, right? So over here you have what, a greater amount of volume, which is 385 what centimeter cube, right? And lesser amount of what, of pressure. So they can't be at the same level. In Boyle's law, you have an increment in what, in pressure, and you have a decrement in what, in volume. Increment in volume, decrement in pressure. That is how it works. So let's solve the second example. Let's solve the second example quickly. So the question says 200 centimeter cube of a gas has a pressure of 510 millimeter mercury. What will be its volume if the pressure is increased to 780 millimeter what, mercury, assuming there is no change in temperature? Remember, in Boyle's law, which is question number 2, in Boyle's law, temperature is always what, constant, right? So we still have the formula to be pressure 1 volume 1 equals to what, pressure 2 volume what, 2. So 200 centimeter cube of a gas. Remember, over here you have your 200 centimeter cube, right? Over here you have your what, 510 millimeter what, mercury. So which means this is your first what, parameter, because you have been given your volume, you've been given your what, your pressure. So this becomes your what, your first parameter, right? So the first parameter, which is P1 and what, V1. So your P1 is what, 510 what, millimeter mercury. Your V1 is your what, 200 what, centimeter what, cube. So your P2, which is what we're dealing with, which is your second parameter. Your second parameter is your what, P2 V2. So over here, what will be its volume, which means volume is not what, is not given. So yeah, it becomes what, an unknown. If the pressure is increased to 780 millimeter what, mercury, right? So from the formula, we are going to make this V2 subject of what, of formula, which is V2 equals to P1 V1 all over what, P2. So please, when you get into the examination hall, like those of you in 100 level, you still meet gas law. Those of you in your SS1, you still meet gas law, either first term or second term. Then most of you who are in SS2, you see do application of gas law in your physics. So you have to understand these basics and how to answer questions easily, because JAM is 50 questions and then you have 30 minutes to answer 50 questions, and it is CBT, that is computer based test in Nigeria. So that is how it works. And then even in abroad, you have time to answer questions. So you can't be wasting time in the exam hall thinking about what to do and what not to do. I've told you the easiest approach. Once you see volume, pressure attached together in the first part of the question, that becomes your first parameter. But if the volume, assuming here the volume was not given, let's say this, let's say if this volume was not given, they say dash of a gas has what pressure of this, then let's say what would be its volume. Let's say the volume was given here. This becomes a what? This would have been your first parameter. If the volume was given in the second part of the question, this would have been your what? P1, V1. But since it is being given here, the volume is being given here, and your pressure is being given here, so that becomes your what? Your first parameter. So let's solve this problem. So you have your V2 to be what? Your P1 is 510 millimeter mercury times V1, which is what? 200 what? Centimeter what? Cube, all over 780 millimeter what? Mercury. So in that case, your V2 is equal to, so mercury cancels what? Mercury, right? So this question, like this particular question, is mostly in mercury. We have other questions that the pressure will be what? In atm, which is atmosphere, and the pressure will be what? In liter. And check my next video. I'm going to do a video that has what? A different question about this. Different question that you see millimeter, that you see atm as the pressure, and then you see what? Diameter cube or liter as what? As the volume. So millimeter mercury cancels what? Millimeter mercury. So you're left with what? With centimeter cube, which is what? Your volume, right? Centimeter what? Cube. So 510 times 200 divided by what? 7 what? 80. You get what? 131 what? Centimeter what? Centimeter cube. So this becomes our what? Our final answer. So if you're solving any problem that relates to gas law, don't forget your units, because it is very, very important. Like I do tell my students, if I don't see your units, so if this question is 5 marks, I'm going to give you 2 marks, because I wonder how you will solve a problem up to this level without remembering the units. So the unit is very, very, very important, because I can, if you write 131 for me, I can decide to add Kelvin to it, and over here you're having volume, then I will fail you. So now check, I'm going to solve more questions in my next video. I'm going to solve more questions relating to what? To Boyle's law. I'm going to solve 4 questions which has atm as what? As pressure, and liter for volume. So I'm going to solve that in my next video. Please share this video and hit the notification button. Subscribe, share it so that others can see it. Thank you very much. See you in our next video. Bye.